Section 3.5 is about mental math and estimations. And we're still working in whole numbers as we were before. But what we're going to be working with is estimating and being able to do things in our head. That's the idea. Now, of course, the nuance of that is I can't see the inside of your head. So you have to write down what the inside of your head is thinking for me. Okay? But recognizing that this is math you're doing in your head. Everybody with me on that? All right. So let's take a look at some examples. Mental math addition. And one of the ways to do mental math addition is we can talk about adding from left to right. So instead of adding 46 plus 38 in the old-fashioned way where we do it by the columns and so forth, it's the old-fashioned with the standard algorithm where we look at the columns where we are, one of the ways to do this in your head is to add the place values. So I'm going to show you what you're doing in your head. First, you're doing it in your head, but you can actually add the 40 plus the 30, and what do you get? 70. And you can add the 6 plus the 8, and what do you get? 14. And this is actually, this is mental math. This isn't estimation yet. This is mental math. And then you can say, well, I know 70 and 14 because there's a nice 0 in there, like zeros. And what's 70 plus 14? 84. And it doesn't have to be a 2-digit plus 2-digit number to do this, but this is the idea. You add the place values. Okay, so you're just working with the place values. And by doing so, you end up with a 0 at some point that you can add to the friendly in your head. Breaking up and bridging. All right, so breaking up and bridging is the idea of taking the first number, and what we're going to do is we're going to add something to it, but we're not going to add 38. We're just going to add 30. So what's 46 plus 30? 76. And why is it friendlier to add the 76 as opposed to, I'm sorry, to add the 30 as opposed to adding 38? Because I've got a 0 in it, right? And I end up with no carrying. I mean, that's the kicker, right? There's nothing that exceeded the value of the place values that I'm in, and I don't have to carry anything. Are you with me? Okay, however, at the end, you still end up having to add the 8 to it. You're just adding the 8 to the 6, kind of like we did on the previous problem. And you know 6 plus 8 is 14. But whenever you add in this right-hand column, it just increases the left one by 1 at that point. I don't actually have to add much to it. I'm just increasing by 1 because I have the value that I carry along with. This is breaking up and bridging. So you're breaking the 38 up into 30 plus 8, and you're adding this. Okay, trading off is one I actually mentioned. I called it something different, but trading off I mentioned in the last section, or maybe it was in your homework, I can't remember. But I've mentioned it today out loud in class. Trading off is the idea that if you take a look at the 46 and the 38, I would really much rather add the number 40 instead of the number 38. Wouldn't you? So one way I could do that is I can say, well, you know what, let's just change this 38 into a 40, and if I do that, that means I have to add 2 to it. But if I add 2 to an addition problem and I don't really want to add 2, that is, I don't want it to change, well, what else would I have to do? Subtract 2. So I'll subtract 2 from the other value. So 46 minus 2 is 44. 38 plus 2 is 40. And then the whole point was that when I get to this point, I don't have any carrying to do. I end up with 84. It's called trading off. It's almost like what we did when we did the equal additions algorithm for subtraction. Remember that one, the whole point was I don't want to borrow, so I keep adding things. When I'm subtracting, I add it to the top and I add it to the bottom to keep things equal. This is the same idea here, but I'm doing addition. Since I'm adding, if I add something in one place, I have to subtract it in another place to make it equal. Our pastor likes to say that the whole point of daylight savings time is stupid because it's like cutting off the bottom 6 inches of the ladder to add it to the top 6 inches of the ladder to make the ladder longer. You do that, right? It doesn't change the size of the ladder. This is what we're doing here. We're adding 2 in one place, taking off 2 in another equally. All right, compatible numbers are really cool, and I use this strategy in mental math actually quite frequently, is that I group things together. I'll use this when I'm grocery shopping, and I'll kind of say, oh, well, this one plus this one's about $1, because their numbers are awfully close. So I know something was worth about 40 cents, and this one's worth about, 52 cents. And I say, well, 40 plus 52 is about $1. Okay. So what we're going to do is we're going to put these in pairs so that they're about something else. And some of them are exact. So what are two of them that I could pair up that would be friendly? All right, 60 and 40 is what I hear first. And those are friendly because those add to 100. What else could I pair up? 70 and 30. And those add up to 100. There's absolutely nothing special about the way that I'm doing this. I'm just trying to show you where I'm getting the numbers from. I have not yet dealt with what number? The 50 in the middle. So I've got 100, 150, which is 250. I don't know about you, but that was actually a lot quicker to do than it would be if I counted 4 plus 3 plus 5 plus 7 plus 6 plus. It would have actually taken me far longer to do that. So this is a great strategy. Another thing you can do is if the numbers are not already compatible, you can make them compatible. So let me show you what I mean by that. 35 is a number that's awfully close. Well, if I add 35 and 68 together, I've almost got 100. I mean, they're really close. But what would I need to add to 35 to actually get 100? 65. Okay? 35 plus 65 really is 100. So if I were to take, let me write it this way. This actually is 100, but I'm not really where I need to be because I didn't really have 65. I had 68. So how far am I off? I'm 3 off. So this is not finished. I'm still 3 off. So my answer is 103. Please do not do this. I'm going to show it to you and then immediately erase it. Do not write down what I'm about to do unless you write it down and mark it off. Can you do that for me? And this is one thing to tell you in education. You should never write something wrong on the board because somebody's undoubtedly not going to mark it out. You guys promise you're going to mark it out? Do not do this. Do not do this. Because that bar means equals. What this actually says is that 35 plus 65 equals 100 plus 3 and it all equals 103. The problem is 100 doesn't equal 3. And 100 doesn't equal 103. Right? This bar means equals, so it means this number should equal what's on top. These two right here should equal right this, but this number should have equaled like this. It's in essence what you've done is done this. So no, this equal to this too. Don't do this either. These are not all equal. Are you with me? So don't just carry on with pluses and equal signs. Don't just carry on with bars and additions underneath them. You can do that all on a scratch piece of paper, but don't do it on something that's actually real math, okay? So don't do that. But this is just fine, okay? Where you've done it in 2 separate steps, you've written it in 2 separate ways. That's great. Okay, can we go to the next one? All right, so we're going to do some mental math with subtraction then. Another subtraction strategy a subtraction strategy like the addition strategy is breaking up and bridging. So the 46 minus the 38, what I want to do is I want to I want to deal with the tens place first, in other words. I want to take the 46 and just minus the 30 first. Okay, I'm ignoring the 8, just like I ignored the 8 when I did breaking and bridging before. Because I can subtract 46 minus 30 pretty quick because I have a 0 in there. And 46 minus 30 is 16. Now I'm not quite done. I still need to take care of the 8 that I've ignored. But at this point, it's easier to deal with 16 minus 8 just because the numbers are smaller. And you actually know that fact pretty quick. 16 minus 8 is 8. So you've done it in 2 steps. But they're pretty quick steps. Good stuff. Trading off. Okay, so trading off is just like equals additions or subtraction. We've already seen this method, I should say. I don't want to subtract 38. I'd be much happier with subtracting what number? I'd be much happier subtracting 40. So I'm going to increase this number by 2 so that I can subtract 40. But this is subtraction. So if I increase the bottom by 2, that is I'm going to subtract 2 more, what do I have to do on top? I need to increase the top by 2 as well. Right? This is like saying that I want to stand next to my brother and we're standing barefoot, and if I put on some platform heels and I go like this, then if we want to keep this the same distance apart, he's got to wear the same size shoes I do. Okay, so if we increase my height by 2 inches, we've got to increase his height by 2 inches to keep the difference the same. And then 46 plus 2 is 48, and then 48 minus 40 is 8. I like subtracting with zeros. It's much friendlier. Adding with zeros, subtracting with zeros, easy zeros. Okay. Ready for 6? Okay. We're going to deal with a little bit bigger numbers on this one to show the strategy. This is 4,600 minus 3,400. And one idea to do this, and this isn't all that exciting of a strategy, is to just ignore the zeros, which is in essence what you do anyway, right? What you're really doing when you do this problem is you're ignoring the zeros, and you're really wanting to know what's 46 minus 34. And what is 46 minus 34? 12. And then I'm going to take the zeros that I ignored and I'm going to put them back on. You're just dropping it here from ignoring them. All right. Next one. Multiplication. We're just flying today. And addition and subtraction, everybody's multiplication. Multiplication, front end multiplying. All right, so front end multiplying is the idea of it's not the standard algorithm, right? It's not multiplying the standard algorithm. What would I multiply first? Let me ask you that. What would I multiply 5 times 6, right? So I would multiply what's in the ones place first. That would be my first thing to do, okay? What front end multiplication does is actually multiply, what do you suppose first? The 4 and the 5, the front parts first. So what I'm actually going to do is I'm going to actually multiply the 4, but the 4 is really 40, and you all recognize that, right? We've worked with this idea before. So we're going to multiply 4 times 5, and we're going to get what? 200. And then we're going to multiply the 6 times 5, and we're going to get 30. And then again, kind of like one of the different things we talked about on the last class or the class before, the benefit to doing that is that I don't mix my multiplication steps up with my addition steps. Because now I need to add these results. There's lots of zeros in this particular one. So what is 200 plus 30? 230. Now, compatible numbers are also a very nice strategy for multiplication, that you're looking for something that's not the same way compatible, right? So in the last one with the addition, I was looking for things that added up to 10, and that's really what we were looking for, right? We're awfully close to it. Here, I don't want things that add up to 10. That would be completely and utterly unhelpful because I'm multiplying. Agreed? But it might be nice to multiply some things together that gives me zeros, right? Like multiples of 10. Yeah? So do you have one, Mackenzie? 4 and 5. 4 and 5 would be nice. So if I take these two and I were to multiply them, that gives me 20. Anything else that might be nice? There's a couple different options, by the way. Either the 8 and the 5 or the 5 and the 2. I'm going to go with the 5 and the 2 because I heard that one from the most of you. So 5 times 2 is 10. And then I needed that 8 in there at some point. I don't care where you got it, but you got it in there. Okay? And if you chose to deal with it the way that Brendan suggested and use the 8 instead of the 5, that's okay too. All right, so 20 times 10 is 200. And then times 8, 1,600. And I don't know about you, but my natural inclination says that's a lot easier than doing 4 times 8, which I know is 32, but then I'm going to do 32 times 5. I don't want to do 32 times 5. And I certainly want to take whatever that result is and multiply it by 5 again, and then double it. I don't want to do it that way. This was really quick and dirty, and it gave me the right answer very quickly. So this is a very nice strategy. We're going to think about money. Do you like money? Whether you really think about it much or not, you think in money a lot. I think in money a lot. So if you take a look at 46 times 5, how could you use this idea to think in money? What's that? I don't want to round. I want to give the exact answer. It's like 46 nickels. Everybody with me? What's 5? It's like a nickel. Okay? But nickels aren't so friendly to count. But what are? Quarters? quarters are? Dimes are really nice. Let me use dimes on this one. I want to change that nickel, that 5, into a dime. How could I do that? Multiply by 2. Okay, so let's try this. If I turn nickels into dimes, what happens to the number of coins I have? Half them, actually. Yeah, I have half as many coins if I have it in dimes as I do if I have that same amount of nickels. So if I double, and this sort of idea of doubling and then halving, we could do this with anything. It just happens to work really nicely when we're thinking about money, because we think about it that way. I would much rather have, how many dimes would this be? It'd be 23. I mean, I still don't want 23 dimes, don't get me wrong, but I'd much rather have 23 dimes than 46 nickels in my pocket. Okay, and you can imagine doing that. I mean, there's a physical description and image that goes along with this idea. And then this would become 5 times 2, which is 10, and I like that too, because 23 times 10 is a lot easier to multiply. What is it? 230. Excellent. All right, so why would I think, or why would this second one be grouped in here? How is this one thinking about money? The quarter. Where do you see the quarter, Haley? The 25. It's like having a quarter, right? 25 cents. But again, I don't really want to carry a whole bunch of quarters, certainly not 44 quarters around in my pocket. What can I do? Okay, divide the 44 by 4, because what am I doing with the 25, Haley? All right, so I'm changing, exactly, I'm changing my quarters into dollars. So I have 4 quarters in a dollar. So if I change that 25 into a dollar, I would do that by having 4 of them, so I multiply them by 4. I would have $1, or 100 is the number I'm getting down here at this moment. And I would divide this one by 4, just as you mentioned before as well. So I don't have 44 quarters anymore. I have 11 dollar bills. I know that looks funny now because I've got such a large number on top and the bottom, but it doesn't really matter because you can multiply that really quick. There's number 100 there. Yeah, 1100. Now, what that really told you is that you actually have 1100 pennies or 1100 cents. But that's $11 if you put the decimal in there. You see that? And that is $11. So that's 1100 cents. Do you like multiplying with tens and hundreds? They're easier to work with, and that's kind of our goal when we're looking at these, is how can I do it easier? All right, what do we have next? Awesome. Okay, division. Division has compatible numbers, but we're going to do the breaking up the dividend first. All right, so breaking up the dividend, this idea has to do with taking a look at the numbers, and let me pause for a second and just say this. Not all these strategies work for all numbers. You guys are seeing that, right? But having lots of strategies gives you options. So if you see one strategy that tends to work for one kind of problem you're working in, you have that option. But they don't always work. Like if I were doing that last slide and I were adding or dividing, or sorry, multiplying by 3, how many coins that deal with 3? That's not so helpful. So thinking about 3s and money is not going to work. Okay, the same idea on this one. I'm going to divide this. But I'm going to think about it by breaking it apart. So I've sort of broken this, I don't know, in half, if you will. Right, so how many times does 9 go into 63? 7. Somebody said it, 7. Okay. How many times does 9 go into 18? 2. Now the danger in here is you telling me that this goes in 72 times, because that's not what happened. Okay. The 63 there was actually the number 6,300. Do you see it? So what we really did when we did this, I'll still use green, that's fine, is we did 6,300 here and 18 here. And so if you went into 6,300, it went in 700 times. And if you went into 18, that really is 2. I mean, that's legit, that's 2. So what's the result really? 702. And again, that worked nicely because 63 and 18 both happen to be multiples of 9. So is it going to work all the time? No, but if it does work, it's friendly. Okay. Now, This one does not have this ability. Like I could try to do this where I did 5 and I did 42 and I did 5, and that's not so friendly because 5 doesn't go evenly into 42. Agree? But there are ways that this can be done in a helpful way. For instance, instead of writing this as the way I just did, I could write this as 400 plus 25. So I split it differently. Right? So I don't always split it in the same spot, but if I split it this way, it's helpful. So how many times will 5 go into 400? 80. And how many times will 5 go into 25? 5. And this result then gives you 85. All right, that's it for mental math. The next thing we're doing is the estimation stuff, okay? Computational estimation. The first one we're going to talk about is called front-end estimation with adjustment. Say that 4 times fast. All right, so front-end estimation means that you take the numbers at the beginning and you add them together. That's the front-end part. So 3 plus 4 plus 2 is 9. So in essence, that gives me 900 because it's in the hundreds place, right? So this so far is 900. And if you were doing just flat out front-end estimation, that would be the answer. That's the front-end part. Okay, you just take the first number, you add them all up, and you're done. The adjustment part means that you take a look at the numbers at the end, and you see if you have any sort of natural pairings. They don't have to be exact. This is estimation, but you're looking for things that are nearly compatible. So if you see any of those numbers that look nearly compatible, come on, get away. These two right here look awfully close to what? The 32 and the 62 are almost 100, aren't they? Remember we did 65 and 35 before? I mean, they're a little bit short, but they're almost 100. So these two right here get me awfully close to a 100. So you're looking for nearly compatible numbers that you can sort of just group together, say, I'm about 100 right there. This is what I do at the grocery store, right? I group the item that was 42 cents and the item that was 52 cents, and I say, that's about $1. By the time we add tax, I'm probably short, right? But that's what I do, okay? You kind of group them together. So you've got the 900 now, the 100, and you've got the 25 that you didn't deal with, but I can certainly add it in now, and my result is about 1,025. So this is my estimation. And it is an estimate. It is not perfect. It's actually a little high. But it's close. Better to be a little high at the grocery store than a little low. But that would work. This is an estimation. Grouping to nice numbers. Again, numbers that are nearly compatible. What pairs of these things might we want to sort of throw together and say, ah, that's about 100? 7135 look like a good pair. This one's about 100. What else? Yeah, the 42 and the 64 look pretty close to 100, right? And then the 55, it's about 50. Leave it at 55 if you want. I don't even care. But either leave it at 55 or you say that it's about 50. And you end up with about 250. And just to give you some perspective on the matter, when I did the problem in my notes here, I didn't end up with 250, and I'm okay with that. I grouped them differently, and my result was about 270. Because I'm doing what in these problems? Estimating. So it's okay if your answer's not exactly somebody else's. I mean, there's definitely things you can do to do it wrong. Don't get me wrong. You can definitely screw it up, okay? But there's other things that you can do that just because they don't match somebody else's doesn't make them wrong. Okay, can I do this last slide, and then I'll put the other two out there for you afterwards? Are you okay with that? Okay. Clustering is the next one. Clustering happens again in very specific situations. Take a look at all those numbers. They're all almost what? They're about 500, aren't they? They're all clustered around the same thing. So these are all about 500. So what we're going to do is we're just going to turn them all into 500s. You can write it as multiplication or as repeated addition if you'd like. Do I have 5 of them? So what is 5 times 500 or 500 added together 5 times? Right, 2,500. Again, does it work all the time? Certainly not, but when it does, it's a friendly way to say, I'm about at 500 times 5 or 2,500. Rounding, you guys know what rounding looks like, and unless you're told, you get to pick where you want to round to. So let's first round to the thousands place just for practice, and then we'll round to the hundreds place just to see what that looks like too. And then we'll stop. All right, the thousands place means when I look at the 4,789, I'm taking this 4. I will either leave it at 4 or I will round it up to a 5. How do I decide? Based on the hundreds place, the 7. This 7 is a 5 or larger, so I will round my 4 up. So this is 5,000. 3,000. I look at this 1. This 1 is 4 or below, so I will leave the 3 a 3. Which gives me a result of 8,000. It's rounding. And again, if you're not told, you get to pick, and that would be fine. Well, let's do hundreds just so that we can see that it will look different depending on how you choose to round, if you choose. 4,789. This is my hundreds place, the 7, so I look at my 8. The 8 tells me I'm going to take the 7 and do what with it? Round it up to a 8. This is 4,800. 3148. The ones place is the hundreds place. I look at my 4. The 4 tells me I'm going to do what? Leave the 1 alone. The result? 7,900.